All right, let's go ahead and get started with the second part of this lecture. I won't go through the announcements in significant detail. I'll just sort of get right into it. The only thing I'll mention, and it's somewhat ironic, we're going to be discussing computational tools, and I'm actually recording this lecture from my hotel room. I'm currently at a conference right now. So forgive me if I have any technical issues as I go through this lecture. Hopefully everything will go well, but we're going to be discussing computational tools, so there'll be some calculations that go with this. So let's just sort of get right into it. We're going to be discussing really sort of two issues on the exam. So first off, like ethics, this is a somewhat short issue or short topic on the exam. Fortunately, unlike ethics, you know, as I mentioned in that lecture, one of the problems with ethics is that there's no real problems to do. There's no calculations. There's no, and because that can be somewhat difficult to master some of that, but that's not really the case with this topic. There are some very clear problems that we can do, and some very clear challenges that we can overcome. Now, there's two topic areas that we're going to be dealing with on the topic of computations. And that's looking at spreadsheets, which I'm going to cover actually later. The other aspect is what's called structured programming. And I think a lot of times many students see this, especially your civil engineers and your students that don't really deal with programming very commonly. They look at this and they go, oh no, I'm going to do horribly on this. Actually, I think you'll find that this is a fairly straightforward section on the exam. As long as you follow what's going on in the topic, I think you'll find this is pretty simple. I have 6 problems for us. Some of them are on programming, some of them are on spreadsheets, but I think you'll find that these are all very, very easy challenges to meet. So first off, let's start with this programming problem. So I have a structured program in this box over here on the right, and it contains 6 lines of code. And so the question is, what is the value of y after this program segment is executed? And so when you're dealing with problems like this, the easiest thing to do is just take it a line at a time. The one thing to keep in mind is that a program will execute this code one line at a time. So literally take this program one line at a time and ask yourself, what's the return? Now, I'm looking at this program, and in the end, there are 2 values, y and b. So if you want to keep this simple, what you could do is maybe you could handle the problem like this. Maybe you say, I have a line here. I have y, and I have b. Okay, so let's treat this as a computer would do, and let's execute this program one line at a time. Let's see what happens. Let's start with line 1. So let's say this line here, that this line is executed. Well, if this line is executed, what do I know? I know that y is 4, and b, you could say it's 0. You could say it hasn't been defined yet. I'll just sort of leave it as a blank. We'll say it hasn't been defined. Okay. So what about line 2? Well, line 2, what did it do to y? It didn't do anything to y. Y is still 4. What about b? Well, now we have a definition for b. Oh, happen again. I have a feeling that might happen a couple times. Didn't do anything to y, but b is now 4. And then just take it one line at a time. Now, what does line 3 do? Line 3 does something to y. It creates a new value of y. So I can tell you b doesn't change. Didn't do anything to b, so b is still 4. What did it do to y? Well, it's saying 3 times b minus 6. Well, what is 3 times b minus 6? Well, 3 times 4 minus 6. 3 times 4 is 12. 12 minus 6 is 6. So now we have a new value of y. Pretty straightforward. Now, we get to the interesting part. We have an if-then statement. So the way that this would work is if this statement is true, then this code would be executed. If the statement is false, then the line wouldn't be executed at all. And that's generally how if-then statements work. So the question is, it says if y is greater than b, then this happens. Well, is y greater than b? Well, I guess what I'll do is I'll say, yes, that is true, because 6 is greater than 4. If that's the case, then y equals b minus 2. So this is another instance where b doesn't change, and y is b minus 2. 6 minus 2 is 4. Then we go to line 5. Oh, apologies. Then we go to line 5. If y is less than b, is y less than b? No, y equals b. So nothing happens. What about 6? If y equals b, yes, then y equals b plus 2, y equals 6. And there you go. All in all, I think that should be pretty straightforward. Just go ahead and move on to the next one. And again, if I do some switching between slides, I apologize. Technology might be a little iffy with me today. Okay, so problem 2. I have a structured program that contains the lines of code shown in this box, and for which input values of x will the output value of t be equal to x? Okay. Might seem like a difficult problem. I think we're going to find it's pretty straightforward. I want to sort of go through 2 different solution strategies. One of these solution strategies is to just try these numbers out. And that is a very valid option. In fact, I do want to go through that exercise to show you that it'll work. Okay, so if you look here, look at my choices. I have A is 0, B is 0 and 5, C is 0, 5, and 8, and D is none of the above. So I really have 3 numbers I'm working with, 0, 5, and 8. And so maybe what I ought to do is plug each of those numbers into this program, and let's just see what I get. So let's just play around with that. Let's see what happens. Okay, so X and T, because let's just be clear on how the program works. I input value of X and I output a value of T. So I plug in X, I get out T. So let's plug in an X value of 0. What happens? Well, I look at the program, I input X, and then the program asks, well, is that value less than 5? Well, 0 is less than 5, so that's true. And if that's the case, what do I do? T equals X times X divided by 16 minus X. So that's going to be the equation that I use. And if I plug in a value of 0, what do I get? I get 0 divided by 16, and so that's 0. So 0 works. If I plug in 0 for X, I get a 0 for T. That's a choice. So right off the bat, that's not an answer. Because if I didn't do anything else, I know that at least A is a possible answer, so D isn't it. Okay, what about 5? Well, if X is less than 5, then this happens, otherwise the following. So do I execute line 3 or do I execute line 5? Well, I execute line 5 because X isn't less than 5, X equals 5. And so what do I get? Well, on the top, I get 5 times 5 is 25. On the bottom, 10 minus 5 is 5, so it's 25 divided by 5. There we go. So 0 works and 5 works. So that's not the answer, because I got 2 values that works. Now what about 8? Well, with 8, I'm not going to execute line 3 because X isn't less than 5, X is 8, so I'm going to execute this. So I have 8 times 5 is 40. 40 divided by 2, that's 20. Okay, so first off, before we try and handle this problem in a more rigorous fashion, this is a very real strategy on the exam. Just plug in the values and see what you get. So that isn't the answer, that is. Now, That's one way of handling it. Another way of handling it is to try and be a little algebraic. For instance, if I take this first equation, the first equation is t equals x squared over 16 minus x. That's just me writing it in algebraic notation. And so the problem is asking for what values, if you input x, do you get an equal value of t. And so algebraically, what I could do is I could set t equal to x and solve and just ask, well, what values of x can I plug in and get the same value on the right-hand side as I do on the left-hand side? And let's just do some algebra. Let's multiply both sides. So x 16 minus x is x squared. And so multiply that out. So 16x minus x squared, because you got to multiply the x out, x squared. And then let's add everything over to the right-hand side. So this becomes 0. So move everything on over. Move everything over to the other side of the equation. So I have a negative x squared. Add that over. That becomes 2x squared, and the 16x minus 16x. So factor. And so I solve this, and I get x equals 0 or x equals 8. Well, wait a minute. Why didn't choice C work? Like, why didn't 8 work? Remember, this equation is just solving the algebra out. But remember, if I plug in a value of 8, that doesn't get executed on line 3. It gets executed on line 5. So that value of 8 doesn't work. Okay? So then you would do the same thing for this equation. And you'd ask, well, what values, you do the same thing. You'd say x equals, you would get x equals 5x over 10 minus x. What is happening with my pen? I apologize. Over 10 minus x. And when you solve this equation, you get x equals 0 or x equals 5. And so basically what you're finding is that this is the only valid solution for equation number 1, because the values of x have to be less than 5. And this is the only valid solution for equation 2, because the values have to be greater than or equal to 5. And so that's why the answer is B from an algebraic perspective. But I want to be crystal clear. You can just plug the values in, and you'll get the correct answer. Okay. Now I'm going to move on to the next problem on purpose this time. Again, I apologize for that. Okay, now the rest of the exam is on spreadsheets, the rest of the review. And they go from pretty simple to, I don't want to say complicated, but really the only thing that makes these problems, I don't want to say complicated, is the relative and absolute addressing. That's just a fancy way of referencing the dollar signs that you put in your formulas in Excel to lock the rows and columns. If you can handle that, then you can handle just about anything that will get turned on the exam. And one other nice thing about this topic is it is so easy to study. Just open up an Excel spreadsheet and start copying formulas around, and I think you'll pick up on the patterns pretty easily. Okay. So first off, in a typical spreadsheet program, what cell is directly to the right of cell AB4? And here are our choices. There's not really any math. The answer is just B. And I promise it wasn't on purpose that the last three questions all had a choice of B. That was totally by accident. But again, this just this just furthers my point. In the show here, keep these. I mean, again, you can just open Excel and just look. So cell AB4, just scroll over. Remember the columns, so here's just a little bit on the anatomy, okay, so of a spreadsheet. The columns are referenced by letters, the rows are referenced by numbers, and then your columns start off in, along the alphabet. Then when you get past Z, the references start using 2 letters, so AA, AB, AC, AD, so on and so forth. And so cell AD4 is that cell. That's AD4. And so, or sorry, AB4. The question was referencing AB4. Apologies. So AB4. So what's next to AB4? Well, it's AC4. Okay. So that's pretty straightforward. Okay. Now, here's another one, and this isn't that hard once you see the trick, but there's a very, I guess, easy thing to miss with this is how many individual spreadsheets are contained in the range between C3 and J12. And so first off, because we're going to be doing some calculations, I'm going to sort of refer to this as column 3. And so if that's column 3, what would J be? And so you do the alphabet, that's going to be column 10. And so, you know, A, B, C, D, E, F, G, H, I, J, so that's column 10. Okay. Now, let's take the rows. If you're going from row 3 to row 12, how many rows are contained in that range? And it's tempting to say 9, you know, because 12 minus 3 is 9. But that's not the case. It's actually 10. Okay. And again, if that's hard to see, you can go back to the spreadsheet. Okay. So first off, C3 to J12, we're talking about that range right there. And so why is it 10? Well, it's true, that's row 3 and that's row 12, and 12 minus 3 is 9. But think, let's say we were talking about between row 3 and row 4. Well, 4 minus 3 is 1, but you have to add 1 because we're talking about that range. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're ultimately talking about 10 rows, and the way that we get that is we say 12. We say it's 12 minus 3 plus 1. And so that's 10. And so if that's the case, how many columns are there? Well, do the same logic. 10 minus 3, that's 7, plus 1 is 8. And so the answer, if you have 10 sort of cells on one end and 8 along another, that's a total of 80. Now, I'll show you a couple tricks to eliminate that. So again, here's our range, and you can look and you can see very easily 8, you know, because I have 4 here and 4 there, so that's 8. You can also just start counting if you want. Here's another thing you can do. If you highlight and you look up here in the, see if this points out. If you look up here in the top left, you can see it actually hovers. You can see 10 rows by 8 columns. And again, that's just because of that additional range. So again, pretty straightforward, but it's an easy thing to miss because it's very tempting to say, well, I have 9 here and 7 here, and so 63. And so it's easy to say, oh, well, B is the answer, but no, that's not the case. B. Okay. All right, here's where things get interesting. Okay, so for the spreadsheet portion below, the formula shown is entered into cell B2 and copied into cells B3 and B4. What will be the value in cell B4? So here's a spreadsheet, and I have a formula in this cell, and I'm going to copy it into cell B3 and copy it into cell B4. And so what's going to be the value in cell B4? Well, first thing I'm going to do is, give me 1 second. Let me cut that. I wanted that blank so that I could actually start writing in these spaces. Okay. And so this is, if there's any complication, any real complication on the FE, and this is where I would argue that the vast majority of your problems are going to come from, it's going to be from this dollar sign. Now, this problem 5 is what I'd call a little bit more of an easier application of the dollar sign. This one's a little more complicated. But again, I think it's pretty straightforward. Now, the way the dollar sign works, we're talking about the difference between relative and absolute addressing. Anytime that that reference is copied onto another cell, the dollar sign locks your reference. Anything without a dollar sign just copies down. So for instance, if I look at the cell above, it says equals B1 plus a given quantity. The B1 isn't locked, so that just goes down to B2. Now this cell is completely locked. That column and the row are locked, so that's A1 times, and the A2 comes down, that's A3. And so the same thing here. That goes down, that stays locked, that comes down. And so if you've got that, then you can start calculating each of these out. Let's take the first one. So that's B1, that's 111. Ooh, got ahead of myself. 111 plus, okay, ooh. My apologies, my technology. Not going well. Okay, B1 plus, okay, the A1 is locked, so that's 3, and then A2 is 4. So 3 times 4 is 12, plus 111, that's 123. Okay, and see, here's where the fine print comes into play, because that formula was copy and pasted into B3 and B4. And so now we're referencing cell B2, that is 123 plus 3. Then A3, that's 5. So 3 times 5 is 15, so that's 138. And then we reference the cell above, B3, so it's 138 plus 3 times 6. Hold on. What happened there? All right, so 3 times 6 is 18. 18 plus that, 156. All right. Boom. Okay. All right, so that's an easy one, you know, because the row and the column are locked on that reference, just that you're always referencing cell A1. Here's where I think it gets a little more challenging. So what we've got here is a situation where only the row is locked, and only the row is locked, but the column remains free on that one cell. So when you copy and paste these formulas across from different locations, you got to be very careful as to how you do that. So with this problem, we have a formula in cell C2, and it's copied into cells C4 and D3. And so what are going to be the values in this cell? Now, let's step away from the computational tools aspect and the Excel spreadsheet aspect, if you will, of this problem. Look at the choices. Let's take the first values, or in other words, what would be in cell C4. And if you look at each choice, I've got what, 0, 60, 16, and 13. They're all different. And so from a strategic perspective on the exam, I only have to do one of these computations in order to get the right choice. I don't have to go through and do both of them. And so that's kind of nice. Same thing on the second choices. They're all different values. Let's just play around with this. Let me do my little trick again. I don't have my keyboard hooked up because I'm using my Microsoft Surface, and I wanted to keep that free so that I could write on the screen. Okay, so here's my formula in this cell. What's my formula going to be like in this cell? Well, again, and actually let's I apologize. Let's also put a formula here. Let's sort of do these in tandem so that we're referencing these appropriately. Okay. First off, so we have two cells being multiplied by each other. The first cell is not locked at all, so it's B2. So if I move this over one, this is going to become C2 over here, and down here, it's going to become B4. You know, going down the rows, so just go down, add 2, go over a column, so you add 1 from B to C. Times. And here's where you got to pay attention. Okay, so cell A1, the row is locked. So what that means is if I go up and down, the row remains fixed. So down here, this is going to be A1 because the row remains fixed. But over here on this cell on the right, the row remains fixed, but not the columns. So that's going to become B1. And so once you figure that out, the rest is pretty straightforward. This C4 is going to be B4, which is 6 times A1, which is 10, which is 60. So we already know that's the choice. But if you want to be thorough, sorry, not B3. If you want to be thorough, you can say D3 equals C2, which is, we have to actually go through and do this. Another actually reason why we can only do one. It's actually more strategic to do that one. I'll comment on that again. Let me go ahead and finish this out. Let's do C2. It's B2, which is B2 is 4 times. Sorry, my pen is not happy right now. 4 times 10 is 40, and so that becomes 40 times 11, which is 440. Okay, all right. So just to sort of recap, by copying this cell down, if you look at B4 and A1, B4 and A1, I'm looking up here on the spreadsheet, refer to that cell and that cell. So the calculation was pretty simple, whereas cell D2 referred to that one and that one. So actually, to do that second calculation, we had to first compute C2 and then compute D2, whereas to compute the lower one, all we had to do was compute that one computation. We could just do that directly. So it's a little bit of a strategic perspective. Honestly, though, I mean, there's a little bit of strategy there. You know, you could sort of look into it and you could say, well, maybe I'll do the bottom one, so I only have to do one computation. But I think that these problems, honestly, if you understand the relative addressing, understand how the dollar sign works, I think these problems are pretty elementary and pretty basic. And hopefully this review as a whole really removed some of the mystery, if you will, regarding structured programming and spreadsheets on the exam, because this is a computational tools section in a nutshell. I also want to mention this is pretty much the same thing that other majors as well would experience. I mean, civils, mechanicals, what have you, especially mechanicals have this section currently on the exam as well, and it's all basically the same stuff. So hopefully you find this valuable. I'll have some practice questions on the exam that I'm going to upload here shortly. And with that, that's going to conclude the review. Again, I hope everybody has a wonderful evening.